So I'll start from the first class, angle and their measure. This is the class in pre-calculus trigonometry. So the objective here is to draw the positive and negative angles. We then convert from degrees to radians and from radians to degrees. We find the length of an arc of a circle and then area of a sector of a circle. So let's define what is an angle. Two rays that share the common endpoint and they form an angle. So here we have two sides. One is the terminal side, one is the initial side, another is the terminal side. So the shear endpoint is the vertex. So this is the vertex. This is the vertex. Here the ray that remains fixed is the initial side, and the ray that rotates away from it is the terminal side. So this is the terminal side. So in second figure, this is the initial side, this is the terminal side, this is the vertex. In third figure, it is the initial side, it is the terminal side, and this is the vertex. So we see that the rotation of the angle, one is in this direction, which is in counterclockwise this direction. This is in counterclockwise direction, but this one is in clockwise direction. So here gamma, alpha, and beta. So these are the angles. So gamma is in counterclockwise direction. So by convention, we call this as a positive angle. And here alpha is in counterclockwise direction. So it is a positive angle. In here, in the third figure, we have beta, which is in clockwise rotation. It is a negative angle. Now we define an angle in a standard position. So we place an angle theta in a standard position by putting its vertex at the origin. So this is the vertex, we should put this in the origin, and letting it its initial side run along the positive x-axis. So this is the initial side, it should run along positive x-axis. This is the initial side, it should run along the positive axis. So the terminal side can be in this quadrant or wherever. So if the angle is defined in this fashion, then we call the angle is in a standard position. Here the angle is in counterclockwise, so theta is positive. Here angle is in clockwise direction, so theta is negative. Angle is in negative. Now the quadrants and quadrantal angle. If a theta is an angle which is in a standard position and its terminal side lands in one of the two places, either inside the four quadrants, might be here, might be here, or here, or here, or here, whatever, then we say that theta lies in the quadrant. So sometimes the terminal side, this terminal side lies on the y-axis or lies on the x-axis. Lies on the x-axis. So if it happens, we call this as quadrantal angle. Here theta is in a quadrantal angle. So we can suppose another figure here. So this is x-axis, this is y-axis. The initial side should be in this direction. If the terminal side is in this direction, this is also quadrantal angle. This is also quadrantal angle. Now we've defined degree. So the angle formed by the rotating the initial side exactly once in counterclockwise direction. We rotate this exactly once in counterclockwise direction until it coincides with itself. So the terminal side and the initial side coincide with each other. So we call this as one revolution in counterclockwise direction. And it measures 360 degree. So one revolution clockwise is equal to 360 degree. So so 1 degree is equal to 1 over 360 of full revolution. So this right angle, positive 90 degree here, is 1/4 revolution counterclockwise. And this is a straight angle. The straight angle is 1/2 revolution counterclockwise. And this is 180 degree. So these are the problem here. How can we draw the angle in standard position? So 135. So 135, the initial line should be here. So 135 should be greater than 90 here. Here the angle is 90 degree, and 135 we should go beyond 90. So this should be the terminal side, and this angle is positive. So this is 135 degree. And negative 180 degree. So the angle is negative, so it should be clockwise. The angle should be in clockwise direction. So this is the initial side, and this is the terminal side. So this is a straight angle, so it is negative 180 degree. Positive 90 degree means you have the initial side in this direction, the terminal side in y direction, and since the angle is positive, so the 90 degrees in this quadrant. And 495, so 495, we know that the whole, if we have this is the initial line, and if we rotate here in if we use our clockwise direction, counterclockwise direction, then it is 360 degree. So if we start from here up to here, it is 360 degree. So we need 495, so we can add 90 more. So 360 plus 90 equals 0, 5, 4. So 450. Still you need 45 degree. So this is the half of 90. So this is 45. So if you add 45 here, then it will be 495 degree. So it should be equal to 360 here, the one complete revolution, and then plus 90 degree here, plus 45 degree here. It will give you 495 degree. Now radians. So what do you mean by radians? A central angle has its vertex at the center of a circle, and its two rays cut out an arc of the circle. Let's say this one ray, and this is another ray. They cut out this arc, and if this arc has the same length as radius, then we say that this central angle, it should be in counterclockwise direction, then it measures 1 radian. Okay, so we can say that our central angle is a positive angle whose vertex is at the center of a circle. The rays of the central angle subtend an arc on the circle. And keep in mind that the radius of the circle should be equal to the arc length subtended by the central angle. And if these two are equal, then we call this angle as 1 radian. So it doesn't matter, the angle remains the same, whatever be the radius and the corresponding arc length. So on a circle of radius 1, a 1 radian central angle subtends an arc of length 1. On a larger circle of radius 3, the same 1 radian angle subtends a longer arc of length 3. So now our objective is to convert from degrees to radian and from radians to degree. So we have the circumference of the circle 2 pi r. If r is the radius of the circle, then one revolution is equal to 2 pi radians. So 180 degree equals, it is the half, so this is pi radians. What about 1 degree? 1 degree equals pi over 180 radians. So 1 radian equals, this is in terms of degree, should be equal to 180 over pi degrees. Okay, now convert each angle in degrees to radians. So 45 degree equals 45 times 1 degree. So we can write this as 45 times 1 means 1 degree means pi over 180 radian. So this is equal to pi over 4. If we break this into small fraction, then it will be pi over 4 radian. So what about 210? So this is for A. For B, 210 degree equals, similarly we can write 210 times 1 degree, which is equal to 210 times pi over 180 radian. So we can simplify this and reduce into small fraction. That will give us 7 pi over 6 radians. Okay, what about 210 radian? Yeah, that's all. So what about negative 60 degree? So negative 60 degree equals negative 60 times 1 degree, which is negative 60 times 1 is pi over 180 radians. So this is equal to negative pi over 3 radians. And similarly, 100 equals 100 times 1 degree, 100 times pi over 180 radian equals, we can simplify this one and get the value 5 pi over 9 radian. Nice. Okay, so do the vice versa. Convert from radian to degrees. So pi over 4 radian equals pi over 4 multiplied by 1 radian. So convert 1 radian to degree. So it will be equal to 180 over pi degree. So this, we can cancel this pi, so, and then the value will be 45 degree. Similarly, 7 pi over 6 is 7 pi over 6 multiplied by 180 over pi, this much degree. So this cancels out. So the value will be 210 degree. What about the third one? Similarly, we can write pi over 3, the negative value, 180 over pi this much degree. So negative cancels out. So this will be negative 60 degree. This 2.5 radian is 2.5. You multiply this one by 180 over pi degrees. This will be equal to some value, and if we round it, it will be equal to 143.24 degree. Right, so we can convert degrees into radian and radian into degrees. So this is a table that shows the common angle, so we should be familiar with this thing. So 30 degrees equivalent to pi over 6 radian, 90 degrees equivalent to pi over 2, 120 is 2 pi over 3, 135 is 3 pi over 4, 150 is 5 pi over 6, and so on. So now our objective is to find the length of arc of a circle. So on a circle of radius, we have a circle, and the circle has a radius r, and theta is the central angle. If this theta is the central angle, it cuts out an arc whose length s. So the length is s here. Then the formula or the relation between r, theta, and s is given by s equals radius time the central angle theta. So remember, s is equal to r times theta. So from here we can write r equals es over theta, or we can write theta equals s over r. Let's take the example here. Find the length of our circle of a radius 4. So the radius equals 4 meter. Central angle is 0.75 radian. So what would be the arc length? So since we know s equals r theta, so it should be equal to 4 meter times 0.75 radian. It should be 3 meter. Since s is the distance, the unit should be consistent. So s is in meter. So the right side should be in meters. So another formula is finding the area of sector of a circle. So the area of a sector of a circle with the radius r and central angle theta is 1 over 2 r square theta. Okay, so we have area equals 1 over 2 r square theta. So sometimes a is given and r is given. So we can write theta equals 2a over r squared. Sometimes theta is given and a is given. So we can find the value of r is 2 times a over theta. Take the square root. The square root for all. Okay. So find the area of sector of a circle of radius 3 meters found by angle 45 degree. So round the answer to 2 decimal place. So here angle theta equals 45 degree. What is the radian measurement? So we should keep in mind that in order to use this formula, this angle theta should be in radian. So what is the radian equivalent of 45 degree? Equivalent to 45 degree. So 45 times 1 degree, 45 times in terms of radian is pi over 180 radian. So what is the value? Can we divide 180 45? Yes, why not? You can divide by 9, 20, divided by 5, 4. So we can have pi over 4 radian. So what should be the area? What should be the area? Area is 1 over 2 r square theta. So 1 over 2 r squared 3 square theta here is pi over 4 radian. So this will be 9 pi over 8. So if you round this to 2 decimal places, then the value will be 3.53. So the area of sector is this meter squared, because the radius is in meter, so it should be, the area should be consistent with the given information. All right. Okay, so this was for